section 4.2 notes called mean value theorem. So these notes deal with mean value theorem, which is pretty much average. So we're going to be taking the average of something, right? So the mean value theorem states that if f of x is continuous on a closed interval and differentiable on an open interval, then there exists some number x equals c between a and b such that the derivative of c, so the derivative at x equals c, is equal to, that should look familiar, the average rate of change, right, between b and a, or a and b. Okay, so if we slide down, this is basically saying that the slope of the tangent line at C is equal to the slope of the secant line from the points A to B. Right, so the instantaneous rate of change at C is equal to the average rate of change from A to B. There's a song, I am not going to sing it, but if you would like to sing it, it comes from the tune from the Halls of Montezuma. So if you go on YouTube and just look up from the Halls of Montezuma, you'll hear the beat and you can just sing the song. So these notes are really short. There's only 2 pages, 1 page front and back. So let's get right into the examples. So our first example says f of x is equal to 4 minus x squared. Is there a c value where f prime of c is equal to the average rate of change of f of x on the interval -1 to 3? If so, find that c value. So first thing we need to do, because this is asking us, does MVT, right, mean value theorem, exist? So first thing we need to do is determine, is this function continuous? So this function is a polynomial. So yes, continuous. Is this function differentiable? This function is a polynomial. So yes, differentiable. So we know that since both of these are true, MVT exists. Right? So it's a polynomial, so yes, our function is continuous from -1 to 3, and it's a polynomial, so yes, our function is differentiable from -1 to 3. So we know that the mean value theorem exists. So according to the mean value theorem, MVT, there exists a C on -1 to 3 such that f prime of C is going to be equal to f of 3 minus f of -1 all over 3 minus -1. Okay. So we don't know what C is, but we know the derivative of C is going to be equal to this. So let's figure out what the derivative of f actually is. So if we look for the derivative of f, derivative of 4 is 0, derivative of -x squared is -2x. Okay, so the derivative at c should be negative 2c equals, and then f of 3 squared is 9, 4 minus 9 is negative 5, minus f of negative 1 squared is 1, 4 minus 1 is 3, all over 3 plus 1. So negative 2c is equal to negative 5 minus 3, which is negative 8 over 4. So negative 2c is equal to negative 2. So c is equal to 1. So to answer this question, we know that there is a c value where f prime of c is equal to the average rate of change, because the polynomial is continuous on the interval and is differentiable on the interval, and that value c is 1. Okay. So for number 2, this is from the 2013 AP exam. Hot water is dripping from a coffee maker, filling a large cup of coffee. The amount of coffee in the cup at time t, where t is from 0 to 6, is given by the differentiable function c. Selected values of c of t are given in the table. Is there a time t between 2 and 4 at which c prime of t is equal to 2? So this interval is within the interval that we're given, and we know that c is differentiable. So by definition, differentiability implies continuity. So yes, MVT applies, because c of t is differentiable, which implies continuity. So what it's asking is that, is there a value of t where the derivative of t is equal to 2? So since MVT applies, we are going to see if c prime of t is going to equal 2. So from MVT, we know that c prime of t is going to equal, using this interval, c of 4 minus c of 2 all over 4 minus 2. So what we need to know is, does this average equal 2? Because if it does, then we can definitely say that there's some value of t that will equal 2. So c prime of t is equal to c of 4, which is 12.8, minus c of 2, which is 8.8, all over 4 minus 2, which is 2. 12.8 minus 8.8 is 4 over 2, which is equal to 2. So yes, there is a value of t where c prime of t equals 2. Okay, so the main point of these notes is that if our function is differentiable on the interval and continuous on the interval, then we can use the mean value theorem to identify a point C that has the same derivative as the average rate of change of the two endpoints. We'll talk a little bit more about this tomorrow. So if you're confused, just bear with me tomorrow.